Okay, everyone, let me go ahead and close out of my extra stuff and we'll go ahead and get started here. Thanks everyone for joining. It's about time we go ahead and get started. So I'm going to go ahead and turn my camera on here. So thanks everyone for joining. Um, Usual housekeeping stuff. So for those that are on the viewer link with the new technology we have, over on the right hand side of your screen, you have a chat box, Q&A box. You can go ahead and enter questions you have there. Again, I'm playing DJ tonight, so I have two PCs running. For those of you who are on the participate link, which is just Max right now, we go ahead and you can do the group chat on there or just speak up and ask your questions. We do have plenty of room over on the participate side, but I understand that there's some problems getting into it. I apologize for that, but hopefully eventually we'll iron out all these technical issues. So tonight we're going to be talking about weather, and we're going to continue the series. And again, I'm going to go ahead and throw out a plug there. If you missed the session last Sunday with Andy, please take the time to go back into the archives and watch his session on weather. I've never seen anyone teach weather like that, and it was an incredible session, and I will by no means do him justice on tonight's session. So please go ahead and watch his session about meteorology. Two reasons. One, great explanation about how weather theory works. And second of all, I want him to come back and present to us again. So please give him some love. That being said, he talked a lot about the weather theory, how weather patterns are formed, how weather moves across the earth. Tonight, we're going to focus more along the lines of adverse weather, the things that can get you in trouble. And I'm going to start off by talking a little bit about stability, kind of do a wrap up on stability, and we're going to go directly into thunderstorms. And why thunderstorms? And for two reasons. One, it leads into discussions about some other adverse weather conditions you can run into, but mainly because thunderstorms are probably the most dangerous thing that you'll encounter as a VFR pilot. We'll talk about things like icing, but as a VFR pilot, the chances of you running into icing is kind of low unless you get into some other issues. So we're going to focus mainly on thunderstorms tonight. So that being said, let's talk a little bit about stability of the air. We've talked about it a lot, but I want to kind of go back and look at what stability means as far as thunderstorms go. So we talked about air being stable or unstable. And for stable air, we talk about it being resistant to vertical motion. And that's going to be important when we talk about thunderstorms. But stable air is generally cool, dry air. As a corollary, I guess that's the word I want to use. As a corollary, it's often with high pressure systems. So high pressure systems want to push down onto the air mass. But cool, dry air tends to be stable. And what do we see with that? We generally see stratiform clouds. We generally see little or no turbulence in the air, and our visibility is pretty poor. And that's because that air mass is resisting that vertical lifting. So all of that air tends to be smooshed down towards the surface of the air or the earth. So when we talk about unstable air, we talk about the opposite. So we talk about moist air, we talk about warm air, and it's, again, corollary. It's generally with a low pressure system because that air pushes up. And if you think about that, it makes sense because whenever you have poor visibility, all that stuff is trapped down. If you live in a very urban area, all that smog, right? All that smoke gets trapped down there. You have poor visibility. But whenever you have unstable air, all that stuff gets pushed up and you have a clear vision and your visibility tends to be better. So Unstable air tends to lift. And that's what convective activity is all about. So you have a mass of air that wants to lift up, and I always get this wrong, so I made notes, right? So as the air lifts up, the pressure decreases. We talked about that lapse rate, right? As you go up into the air, pressure decreases, right? So pressure decreases, your volume increases, and as a result, your temperature decreases. So you have that. If you watch the Andy session, we talked about the lava lamp, right? So you have these masses of air that want to lift, but what goes up wants to come back down again, and the opposite occurs. So as the air comes back down, the pressure increases, the temperature increases, and you get these motions in the air, and you get these circulation patterns, and that's what convection is all about. So on Tuesday, when we were talking about weather services, I kind of skipped over one section, and I kind of did it on purpose because I wanted to kind of focus on it tonight. And we were talking about SIGMETs. So let my screen load up here. And when we talk about SIGMETs, SIGMETs tend to have a number of items on it. So this is current as of about an hour ago, right? So we have all these SIGMETs in the country going on right now. This is a good day to do this. There's not a lot of thunderstorms, but we'll look at that. So SIGMETs. I'm sorry, my mouse is just going crazy on me tonight. So SIGMETs are significant meteorological conditions. These are the things that are bad for all aircraft. It's not just general aviation, it's all aircraft. And they tend to be things like severe turbulence, severe icing. You notice a theme there, severe, right? Volcanic ash. Volcanic ash is very bad for a turbofan. So dust clouds, sand clouds, these things are very bad for all aircraft. So they are SIGMETs. But there's also convective SIGMETs, and those are talking about thunderstorms, severe thunderstorms, 3/4 inch hail, winds in excess of 50 knots. These are the areas where there's very bad weather. So you look at these convective SIGMETs that we have there, and they're all over the U.S. right now. Convective SIGMETs, they're generally valid for 2 hours, right? And they'll give you an area where they predict the convective activity, i.e. thunderstorms, could occur. You'll also see areas where there's actually thunderstorms, and these are actual thunderstorms where they are actually there. So they'll give you the coordinates. They'll tell you cumulonimbus, so you see CB top above flight level, 45,000 feet, and it's moving west at 7 knots, and it's intensifying. So it actually tells you the movement of that thunderstorm. For the convective SIGMETs, it's telling you the same, it's giving you the same coordinates of where it thinks it's going to be. And these are generally off of airports, nav aids, things like that. And it will also tell you where there's areas of where thunderstorms can kick up at any time. So Max, you have a question here. It says, you said in the beginning, cool air is typically stable. However, is that always the case? The reason I ask is it seems that living in California, the most stable air is in the summer. However, the air is dry. It's relative, right? Cool air doesn't mean below 50 degrees, right? Sure. Cool air means it's cooler than the surrounding area. So conversely, out here in the East, in the summer, so here's a good example. In the summer out here in the East, air in the morning, although it's warmer than in the summer, tends to be a little bit more stable than like in the afternoon whenever all the heat kicks up. It's relative. And cool versus warm is all about the air surrounding it, not necessarily temperature itself. I hope that makes sense.
Does that have anything to do with humidity? So I know, like living in Florida, typically in the summertime, you get very unstable air, large thunderstorms, just because of oh,
did we lose you?
Still hear me?
You're kind of breaking up, so I think I got the gist of it. Yes, humidity has something to do with it, right? So when you add, I'm going to go ahead and mute you, Max. Sorry. So whenever you add moisture into the air, so water vapor is generally lighter than air. Well, it is lighter than air. So moisture decreases air density, causing it to rise. So whenever you have an air mass of one temperature, when you add moisture to it, it's going to rise a little bit more. Adding that moisture into it does change the makeup of the air. I hope that one makes sense to you. It does change it a little bit. Okay, so let's switch back to the convective segment. So I kind of glanced over these, but it's important for you to understand what these segments mean. And I can tell you as a general aviation pilot, when you see a convective segment, don't go flying. There's no reason to, right? Unless you have a mission, whenever there's convective activity, it's pretty well defined that some convective activity is going to happen in your area. The problem with thunderstorms is they're not entirely that predictable. And we'll talk a little bit about why that is. And it has to do with that lava lamp thing. But in a convective area, a thunderstorm can pop up anywhere. That's not to say that a thunderstorm is just going to pop up in one area and not, I'm sorry, I'm switching off here. That's not going to say that one thunderstorm is going to pop up here and you're going to be able to see it from miles away. There's not going to be any problems predicting it. They can happen anytime. So Andy did a good explanation of whenever an air mass is traveling along and it'll come over like on top of a warm parking lot or something like that. That's where that convective activity starts happening. So you can never predict where that actual lifting action happens. So let's talk a little bit about what creates a thunderstorm. So to create a thunderstorm, you need three things. You need moisture. So we're talking a lot about moisture. You need to have unstable air. You can't have a thunderstorm in a very stable environment. It has to be unstable. And you need to have some sort of lifting action. So what kind of lifting action are we talking about? So let me go back to my screen here. Whoops, I pushed the wrong button. Of course I did. So bear with me 1 second. And by the way, I'm pulling up the PHAK as usual. This tends to be our #1 source of information. So if we look at lifting actions, what kind of things can we do? So here's a cold front. And a lot of times with cold fronts, you'll see thunderstorm activities. So when you have this cold air mass here on the left-hand side, moving in from St. Louis to Indianapolis, that cold air is coming down. Colder air is coming underneath the warm air. So it's taking that warm air that's over Indianapolis and lifting it up. Another way that you can lift the air is by what's the word, orographic, so mountains. So if you have a mass of air moving over a mountain, that will cause lifting too. So all you need is some sort of lifting action, and that's what gets things started there. So you need unstable air, you need lifting action, and you need moisture. So what happens when a thunderstorm forms? And we can just move right over here. So over here on this panel on the left-hand side, you see the cumulus stage. So there's 3 stages of a thunderstorm. There's the cumulus, the mature, and the dissipating. So the cumulus stage, and this is part of that test you'll see, is mostly dealing with updrafts. So that air, that unstable moist air is moving upwards into the air. And it continues and it creates a continuous updraft. And you'll see the clouds. And I'll tell you what, let me go ahead, and while I'm talking here, I'm going to go ahead and move my mouse cursor bigger. So you get these updrafts, and that keeps building up the clouds and higher and higher and higher. And it's all that moist, warm air moving upwards. And once you get past, it usually takes about 15 minutes for you to go from the cumulus stage to the mature stage. And these things build up very rapidly. And you can see they go as high as 40,000 feet and beyond. These things can go up to 60,000 feet. They can go way up into the stratosphere depending on how powerful they are. All that moist air goes up, and what happens is that convective activity, so what must go up, what goes up must come down, and you get these, I don't want to call them cyclonic, that'll confuse you, but you get all of this stuff up there. It goes way beyond the freezing area, and up at the top here you start getting your condensation into ice. You have a lot of ice activity here, but at a certain point all that air gets up to as far as it's going to go, and then it starts coming back down. It starts way up at the top as ice, and it hits down into the areas where you're above freezing, and it turns into rain, and it starts raining, right? And that's how you can tell when you hit the mature stage of a thunderstorm, is when water starts hitting the ground, when it starts raining. There's also a lot of electrical action going on here. There's thunder, lightning, but you reach that mature stage whenever the water starts hitting the ground. So this mature stage can last for anywhere from, 15 minutes to 2 hours, depending on the strength of the storm. But during that time, it's mostly water coming down. Once the thunderstorm has reached the point where it's going to start dissipating, now you have mostly downdrafts. And that's because all the energy of all that air moving up is done, and it's mostly moving down, and you'll start dissipating. So as that storm cloud moves up, now it's going to come down, and it's mostly downdrafts. Dissipating stage, you're still going to have rain, but you're going to see those cloud levels come down. Let me grab my notes here real quick here. So here's a side view. If you've ever seen one of these anvil tops, this seems a little bit backwards to me, but the direction that the anvil's pointing, so you can see it's pointing out here to the right, is also the storm movement. I always kind of thought it would leave the anvil behind in its path, but no, that anvil's up ahead of it. And this is due to that lifting and the changes and all of the air pressure moving around, but that anvil cloud starts forming. The anvil starts forming more towards the dissipating stage of the storm. You won't see it until the storm's almost over. But the reason why I point out this anvil cloud is if you see one of those, underneath that anvil cloud is one of the more dangerous areas. But let's be realistic here and talk about a general aviation aircraft. You're not going to be flying around one of these. You want to stay at least 20 nautical miles away from any storm, and if you can help it, stay way beyond that. But in particular, underneath the anvil cloud, because it's way up high in the air, you're above that freezing level, you have a better chance of hail coming out of the anvil cloud. And if you think flying through a thunderstorm is bad, hail on your aircraft is going to cause a lot of problems. So I just wanted to point that out. Let me take 1 second here and take a couple questions. We have one. So from what I've learned, you want to look for the conditions that impede visibility, one being the area between a low pressure system and a high pressure system. Good question. So yeah, so you can always tell where the bad weather is on the way that you're flying. So you can always assume, not always, but in most cases, the bad weather is going to be associated with a low pressure area and frontal stuff. I think maybe we'll cover that later. Let me come back to you on that question about the low pressure and the high pressure. And we have another question here. Is a thunderstorm any more powerful at a certain altitude? i.e., would it have a greater effect on a jetliner at a flight level versus, say, several thousand feet? Well, that's a good question. Powerful, yes and no, because so the power of a thunderstorm, you can tell by how tall it is, right? Because the more powerful a thunderstorm is, the higher it's going to push up all of its activity. Is it any more dangerous at an altitude versus like a higher altitude versus a lower altitude? Yes and no, right? Because when you get in the higher altitudes, you're dealing more with hail and ice, right? Which is bad for any airplane. But generally at those altitudes, it's more jetliners up there versus down lower where we fly in a general aviation aircraft. I don't want hail hitting my Cessna at all because I'm going to be in a bad place really quickly. So it's not necessarily degrees of dangerous as far as what that danger is going to do to your aircraft. I hope that makes sense. While we're talking on that aspect, if you're flying and you see a thunderstorm and you're in your Cessna or your Piper, you will never, ever outclimb a thunderstorm. So you want to avoid laterally, not going above it and certainly not below it. And one of the dangers about flying underneath a thunderstorm we'll get to a little bit later. But anytime you see a thunderstorm, you definitely want to avoid it. Now, one of the problems that we have is it's great whenever you have a thunderstorm just sitting out here in the middle of nowhere and you can see and avoid it. Particular problems with instrument pilots is whenever thunderstorms are embedded in other clouds where you can't see that thunderstorm. So unless ATC is telling you, hey, you have a thunderstorm ahead, or you have weather radar on board, sometimes thunderstorms hide in other clouds and you can't see them. That's whenever they become very dangerous because you don't know that you're flying into one. As a VFR pilot, you're going to avoid clouds, but if you see one of these thunderstorms, you definitely want to avoid it. So talking a little bit about that, when you see a thunderstorm kind of standing out along its own, that's generally what they call an air mass thunderstorm. And they're generally quick living, so 2 hours and below. what you can do, and let me see if I can pull one up here. Let's see. Give me 1 second here while I switch over. And let me. Okay, sorry. Sometimes what happens, and right now what's happening in the middle of the country right now, is you have this cold front. So it doesn't appear to be right now, but what you can have is out in front of the cold front, and it doesn't have to be right in front of it. It can be several miles, 50, even 100 nautical miles ahead of it. You get what's called a squall line. And that's a line of thunderstorms. And squall line thunderstorms are very dangerous. They're very powerful. And they're ahead of the front. So if you're going to use frontal passage as your indicator of whether or not thunderstorms are going to be present and a danger for you, you always have to look out for the squall lines. Generally, if you see thunderstorms in your area, you're not going to go flying anyways. Okay. Let me see if there's any questions here real quick. So give me 30 seconds here. Okay, I don't see any additional ones. So that's generally, that's generally thunderstorm theory. You want to stay away from them at least 20 miles. We've talked a little bit about the life cycle, and I think that covers most of the items that are going to be on the test. Let me do one quick check here. Okay, so let's talk about one of the things that is a result of a thunderstorm, and that tends to be low-level wind shear. But before we talk about that, let's talk about wind shear in general. We've talked about temperature inversions and how that can create shear in the air. So wind shear is any sudden change in the speed or the direction of the wind. And when you're up high, generally, like whenever you have a temperature inversion and you get that shear zone between them, it's generally not a big deal. What I'm talking about is more along the lines of low-level wind shear, which is wind shear that's close to the ground. And thunderstorms definitely are one of the creators of low-level wind shear. But it's important to understand that shear can happen at any altitude at any time. But generally, whenever you have a frontal passage or a thunderstorm, that's whenever you need to look out for low-level wind shear. And think about wind shear, low-level wind shear, and what it can do to your aircraft. So if you're coming in for a landing, for example, in a Cessna, and you're on final approach, and you're going, the approach speed in a Cessna is what, 65 knots, and you're heading into a headwind. If that wind shears to a tailwind and 60 knots, you've gone from 65 knots now down to 40. So that sudden change in wind can have a dramatic effect on your aircraft, and then can actually put you in a very serious situation. You can stall your aircraft, right? One of the things that comes out of a thunderstorm is a microburst, and it's definitely a shear condition. And what happens is, coming out of a storm system, you have a very strong downdraft. So we talked about that. We talked about that dissipating stage where you have those those downdrafts, and look at what can happen whenever you're flying an airplane. So you're taking off from a runway, and you get into a microburst situation, and you have an increasing headwind. You get into the microburst, and suddenly that headwind is starting to shift to neither, and then it shifts to a tailwind. The problem with a microburst is, and it's right here, downdrafts of up to 6,000 feet per minute. There isn't a general aviation aircraft that can outclimb 6,000 feet per minute. So if you get hit with one of these microbursts, and whenever you're low to the ground, the chances of you making it are kind of low. So you have to avoid these microbursts. The good news is a lot of airports now have these kind of alerting systems on them. But generally, if you are flying around thunderstorms or in frontal situations, be very, very careful and understand the conditions around you. I'll show you an example here real quick. I've used this example before in the past, so this won't be a big surprise. But this year in Arizona, this was a microburst that hit Phoenix. Look at, what does this look like to you? It looks like a mushroom cloud. It looks like a nuclear explosion, right? Except for all that power is coming down towards the ground. And one thing about microbursts is they're not always associated with weather or rain. So they could be a dry microburst. So you have to be really careful about when you're flying in frontal passage or storm conditions. Let's switch back over real quick to the wind shear. So let's talk about a couple things that you need to do. So if you're coming in for a landing and you have wind shear warnings. So how do you do that? So a tower can tell you have wind shear. There can be an alerting system, or you will feel a shear whenever you're doing it. So you're coming in, suddenly you're losing speed, you're losing altitude. What do you do in a shearing condition? And the number one thing that you can do in this situation is go around. Full power, get yourself back up in the air, go around. Start climbing, clean up, go back around. And if you are in an area where there's continuing shearing possibilities, make sure you divert or wait a little bit before you come back in. What do you do whenever you have a thunderstorm? So let's say you're a VFR pilot and you're flying along, and for whatever reason you find yourself in a thunderstorm condition. Sorry, I'm going back to my anvil cloud picture here. It's taking me a second. So what can you do if you find yourself in a situation where you have to go into a thunderstorm and there's nothing you can do about it? Okay, so here's a couple things that you need to do. Immediately, you need to get your aircraft below VA speed. You need to get below maneuvering speed. And why is that? We've talked about VA is the speed where your aircraft is going to stall before you do any structural damage, right? So you want to get your aircraft below VA, and you're going to penetrate that storm. If you're in the storm, right, there's no sense doing a 180 because you don't know how this thing is building out. But let's say you have to penetrate and keep going through. All you want to do is maintain a level attitude. And by that, I mean try and maintain your wings level. You're not going to be able to maintain vertical speed. You're not going to be able to maintain your altitude, but you can at least maintain that horizontal attitude and make sure that your wings are staying level. You're going to have a rough time. Turbulence is going to be really bad. There's going to be a lot of rain. But at that point, if you're a VFR pilot, you're going to just go through it. Now, that being said, your primary responsibility is to avoid that storm. You don't want to go into that storm as a VFR pilot. But once you're in it, if you happen to get in that situation, you're just going to have to go through it and do your best. So, so Max is asking, can you do a little bit about best practices on checking for weather practical knowledge? Yes, Max, give me 2 minutes of that and we'll cover that one. Okay. All right, so let's move on to icing real quick. Now, I don't have a lot of visuals for icing. So whenever we talk about icing conditions, so for a normal VFR pilot, you're not going to get yourself in those situations where you're going to run into icing, because in order to get icing, there's two things that need to happen. You need to have visible moisture, which means clouds, fog, those types of conditions. You have to be able to see the vapor in the air, and it has to be below freezing. Those are the conditions where you need icing. So how do you avoid icing as a VFR pilot? You don't go in the clouds, and you don't get into conditions where there's visible moisture, which is exactly what VFR flying is all about, right? But what happens if you do encounter some icing? What are some of the things that you can run into? So if I'm flying along and I enter a cloud and by accident, and there's some icing that occurs, I'm going to see two main types of icing that I'm going to see. I'm either going to see rime ice or clear ice. Clear ice is super cold water that hits the surface of your wings or anything on your airplane and kind of freezes over, like, how do I want to explain it? So kind of like your sidewalks, right? Where you get that clear layers of ice over top of each other. It's clear ice, right? The other type is rime, where it looks more like tiny little snow pellets that keep building up. So it kind of looks like a pile of snow, but it's actually ice on top of it. So those are the two types. And it varies depending on how cold it is, what type you're going to get. So between 0 degrees and minus 15 degrees, you're going to get one type versus the other one. Whenever you learn instrument, you learn more about the types of ice. But what do you do whenever you get into an icing condition? What's going to happen? So your airplane is going to immediately lose some lift capabilities. And I'm sorry, out of the corner of my eye, I'm seeing that there's a problem potentially with the feed. So bear with me for 1 second here while I check it. And okay, cool. It's just my other PC. So I'm sorry if I lost any questions on the other side. So what do you do whenever you get in the icing conditions? You're going to lose some lift. And the big debate is whether you climb or descend out of the conditions. And the big problem with climbing or descending to get out of the conditions is it depends on what the conditions are. So for example, if you have a temperature inversion where there's warmer air above you, your best option is to climb to get out of that ice. And that's also considering that you can actually climb with the ice that you've accumulated on your airplane. Or down below, air is generally warmer in normal circumstances, so you want to descend. You also have to look at how you got into that situation. Maybe doing a 180 is the best choice to get out of that ice. So it's really a situation dependent. The best thing is you penetrated that cloud, you got some icing, so turn right back around because it wasn't icing where you came from. So do a 180, climb and descend depending on the situation, but you want to get out of that icing condition as soon as possible because you can't afford to have more ice on it. Frost is another big thing that people generally don't think about. And frost occurs on the ground whenever you have a surface that's below freezing and your temperature drops below the dew point. So you get dew normally, like in the summer. Well, in the winter, you get frost. So your wings sitting out at night are going to be below freezing, and you get that temperature dew point spread that goes down to nothing, and now frost forms on your wings. You absolutely positively cannot take off with frost on your wings. Even a little bit of frost will severely damage your lift capabilities and your takeoff capabilities. So you have to remove all that frost off of your aircraft before you go. And that's not just saying, like, the first thing you want to do is you want to get your airplane into the sun or into a hangar where there's warmth and you can get that frost melted off of your surface. But you don't want to stop there. You actually want to remove as much moisture as you can, all of the moisture off of your wings, because if you're in a heated hangar and you melt that frost off your wings, if you pull it back out whenever it's cold outside, what's it going to do? It's going to just form right back into frost. So you have to remove that water on top of that as well. So you have to get that frost off before you take off. Do not ever try and take off with frost. Even a tiny little bit will give you a lot of problems. If you take off from an airport that has a 3,000-foot runway, you're in a Skyhawk, for example, you might not be able to make it off the ground. Cool. So Andy covered fog and visibility restrictions in the last one. So I'm going to go ahead and take Max's recommendation here and talk a little bit about checking for weather. So give me 1 second here. And while we're doing that, if there's any questions that come in, and again, I'm back to my single screen here. Sorry about that. So Max, did you have anything in particular you wanted to look at, or? Yes. Okay. Okay. As always, aviationweather.gov is my primary source of non-official weather, right? I also use 1-800-WXbrief.com, and that's where I get my official weather. But let's look at some of the things that you can use to look for adverse conditions. So when you go to aviationweather.gov and you go to the home, the first thing that's going to pop up is a screen that has SIGMETs and pilot reports, and it's going to give you a good idea of where marginal VFR, so that's the blue sections, where there's IFR, that's the red sections, or low IFR, so that's the really bad weather. So it's going to give you a good snapshot as far as what's going on in the country. But what you want to look at primarily from a bad weather perspective, right, is under advisories, you have AirMet and you have GMET, or the AirMet and SIGMET. So under the AirMets, it will give you information such as the turbulence, the mountain obscuration, the IFR, the AirMets that are mostly, well, I don't want to say mostly, that are particularly of interest for us GA pilots. And it'll also give you the freezing level. So if we're getting into the weather or the winter times and the freezing levels start getting lower. So for example, if the freezing level was at, say, 2,000 feet, I know that my potential icing conditions are going to be at 3,000 feet, because I need to have that below freezing temperature for ice to form. So the AirMets give you that. Also under advisories, you have the SIGMETs, and that's where I was looking to show you the convective information, right? So the convective information will tell you where they say convective activity is going to happen. I was trying to find a equivalent on aviationweather.gov, and I couldn't find one. Convection. So 1-800-WX-BRIEF has a better convective picture, but this will give you the outlooks for the next 24 hours, right, or 12 hours. So this will tell you where they think that thunderstorms are going to be. Another thing that you want to look at is under the forecast, you have the prog charts. The prog charts, we didn't go into a lot of depth the other day, but this will give you an idea of where the frontal areas are, and the high and the low pressure areas, and the isobars, right? So again, I said that the stable air generally is associated with the high level pressures, the unstable air with the low pressure. That's not always the case. Don't use that as a hard and fast rule, but this will also give you the frontal passages. Again, if you are a GA pilot, and unless you have some sort of crazy mission, try to avoid flying out in front of a cold front, right? Because these are generally the ones that bring you bad weather. And if you look at the SIGMETs, you see the convective SIGMETs here, and we go back to the prog charts in the same area. Look, there's that cold front that's going through there. So Max asked, do you use DUWATS? How does it compare to aviationweather.gov? I do not use DUWATS. I started to. I used DUWATS many, many years ago. But aviationweather.gov gives me a nice flow. I use aviationweather.gov as my primary, I'll call it planning weather. I use 1-800, WX Brief as my actual weather briefing and my filing. That's what I use. Because it gives me a lot more. And while I'm over here, let me show you what I was talking about. So if I look at severe weather outlook, I don't know if you can see that little one. Shoot. Here, let me switch over. This one's going to be a pain. Okay. Oh, it's not that bad. So they have the convective outlook, which gives you shaded areas of the country where they think there's going to be convective. They have a 1 day and a 2 day. So for the next 24 hours, where do they think that convective activity is going to happen? So this one was valid September 26th at 010 Zulu. And again, this kind of matches that pattern where we see with that cold front. It also matches where we see with the SIGMETs, and it ranks everything from absolutely nothing out here to general all the way up to high thunderstorm risk. I see general, marginal, slight a lot. The higher ones, unless there's actually some known conditions, I don't see that one too often. Okay, fall back to oops. Sorry, folks. Clicking the wrong thing here. Okay. So back to aviation weather. So we talked about SIGMETs, AirMets. We talked about looking at the prog charts. Your winds and temperature aloft, especially whenever you're talking about icing, will tell you a lot about what's going on as far as the freezing level. Obviously here in Boston, just as an example, you can see that the freezing level is between 6,000 and 9,000 feet. And if you compare that to perhaps some of the cloud information, it'll tell you where there's potential icing. PIREPs. PIREPs are extremely important. Again, I'll say it, all the forecasting and all the surface-based weather you can find in the world is awesome, but there's nothing more than an actual pilot report. So here you go. Here's Embraer 145. He's over whatever EMP is on this radial at this distance, and he's getting light rime ice from flight level 20,000 to 21,000 feet. PIREPs are the best place to get information. Obviously, radar and satellite imagery can tell you where things are. But again, because of the nature of thunderstorms, there's not always a good predictability except for whatever you're seeing live. And if we can switch over to, I'll show you Sky Vector, and I'll show you one thing that I've picked out. So here's Sky Vector, and the blue shaded areas are the convective activities. Let's see if I can find one here real quick. Drizzle. Here's one. Okay. How do I do this without losing it? Some weather stations. So again, we talked about METARs on Tuesday, right? So if you read this METAR here, it'll give you the time. It's automatic, your winds, your visibility, your cloud coverage, temperature dew point, altimeter, and the remarks. It's an AO2. And LTGDSNTSW, what does that mean? Okay, so here's a good example. That's lightning, distant, southwest, and northwest. So this automated station was able to pick up lightning southwest of the station or northwest of the station. You'll also see some, so there's another lightning distant. So again, here's this convective area, and they're seeing lightning. But look what's interesting about inside of here is all the areas are VFR. And that's because these thunderstorms that could or could not be coming through here might be very small cells. And they're not taking these fields down to conditions. I mean, broken 10,000 feet, it could be a 10,000 foot tall thunderstorm, or starting a base of 10,000 feet. I was really looking for a VCTS here, and I thought that there was one. There was one earlier. Let's go here. So, but we'll get the idea here. So if you see VCTS in the METAR, that means vicinity thunderstorms. We talked about that on Tuesday, right? So you can tell. So here in the TAF, it talks about how in the vicinity of thunderstorms in the TAF, but in the METAR, you can also see those as well. So let me check real quick and see if there's any questions, and I don't see any right now. So we are right at the top of the hour. That hour went by quick. So I'll tell you what, I'm going to go ahead and stop there. So we talked about convective activity. We talked about stability in the air. We talked about thunderstorms, how they form, what you need to get them going, a little bit about the life cycle of a thunderstorm, and some of the stuff that comes out of thunderstorm, low-level wind shear. We talked about icing. We talked about frost. Andy covered fog and some of the visibility issues. The only thing that I would add that we didn't really go into as far as visibility is actually adverse weather for us. So if you're a VFR pilot, you know that you need to have 3 statute miles visibility. If you've never flown in 3 statute miles visibility, go and do it. You will be shocked to see how poorly that visibility is. And think about whenever you have an aircraft converging on you at, say, 5 miles out and you only have 3 miles visibility. Go out there and experience that. 3 statute miles is not a lot of visibility. And again, we talk about in this program in general, we talk about personal minimums. Is 3 statute miles really going to be your comfort level with VFR flying? And think about that. I don't like flying in 3 statute miles visibility. It's terrible. I can tell you a story about how I was going into an airfield probably 2 months ago, and it was a little bit over 3 statute miles visibility, and the tower kept calling an aircraft as my traffic, and I could not see this thing. And what happened is we both entered the downwind at the same time, and we had about a half-mile separation. I never saw that airplane until I turned downwind. I could not see him off my wing. Now you're sitting there going, well, he was half a mile away from you. How can you not see him in visibility like that? But I'll tell you, that visibility kind of messes with you. But okay, so with that, stay away from thunderstorms. Very bad for you, very bad for your airplane. Adverse weather, I think we covered everything for tonight. I don't see any other questions, so let's talk a little bit about what's coming up this week. This week on Tuesday, we have, I think, let me verify that real quick before I say it, is airport operations. So we're going to talk about all the things around the airport, how you navigate around an airport, who do you talk to, ground versus tower. That's coming up on Tuesday. So with that, I'm going to go ahead and close out. Thank you very much for joining. I hope to see you on Tuesday, and have a good week, everyone. See you later.